Here's integrated 3. It's the closure problem 4-138. And so on problems like these ones, for now the best way to do these is to try to get the base to be the same. So I know that if I have like base 2 raised to a power and another base 2 raised to a power, I can just set the powers equal to each other and solve for x. So I know I can write 64 as a power of 2, because I can go 2 times 2 is 4 times 2 is 8 times 2 is 16 times 2 is 32 times 2. I think if I multiply 2 by itself 6 times, I get 64. So I just rewrote 64 as 2 to the 6th. Now there's an equal sign here. So if these two bases are equal and the two sides of the equal sign are equal, then these two exponents must also be equal, or else we wouldn't have equality here. So then I just take the two exponents off to the side on some scratch paper and I solve. So I just add 1 to both sides and I get x is 5. So we're going to pretty much, on most of these problems, we're going to do that same little technique. Except for this one. This one we can't rewrite it so the bases are the same. So on this one we're going to do something a little different. If I could just get the x, like the x is having the cube root taken of it. So if I could just get undo this cube rooting. I don't know if you guys knew this, but 1 over, like when I have x raised to the 1/3, that's the same thing as cube rooting x. So what I'm gonna do is a little trick. I'm just gonna raise both sides to the 3rd power, right? Because you know how you can multiply the power property or whatever. 3 times 1/3, that just makes it x to the 1. So that's how we're going to take care of this one. So I just kind of undid the cube rooting by cubing both sides. And then I asked my calculator what is 4.7 cubed, and I got this. Actually, it was actually equal to that. Okay, so the next one, letter C, I'm going to use my old trick of writing the bases the same. I can write them both as 2's, and I guess you'll just get used to this. Just when you see a problem like this, just ask yourself, is there any way I can get these bases to be the same? I'm not going to get them to both be 8's, but I could get them to both be 2's, because 2 cubed, 2 times 2 times 2, that's 8. And 2 to the, let's see, 2 times 2 is 4 times 2 is 8 times 2 is 16. So 2 to the 4th. So I got 2 cubed and 2 to the, see, I just wrote the 8. It's just 2 cubed here. And there's my other exponent that came with the problem. And then I wrote 16 as 2 to the 4th. And now I have the base is the same, so I can just take these, I can equate these exponents. So I just wrote them over here on scratch paper, and I had to do some algebra to it. And then I ended up with the x equals 9. Okay, there's a lot of these. Letter D, I'm going to use the same little trick. I'm going to rewrite these with a base of 3. So 9 is 3 squared, and 27 is 3 to the 3rd. And then I just see, like, you multiply, like when I wrote 27 as 3 to the 3rd, that exponent gets multiplied by the exponent was already there. And then I'm going to take these over to the side on scratch paper, and I'm going to solve for x. So I just did some algebra to them, and I ended up with 3/2. X is 3/2. Okay, and then letter D. Letter D, x to the 4th. So on this one, or sorry, x to the 6th. On this one, what is happening to the x is that it's getting raised to the 6th power. So I kind of want to like take the 6th root. Like really what I want to do is take the 6th root of both sides. But my calculator, actually my calculator will let me take whatever root I want if I push the shift button. But another way to look at it would be just to raise both sides to the 1/6 power. So either way that you look at it. And how on earth do you do that if you don't have a calculator like mine? If you just have a regular, calculator that's not this one, you could probably still go 29, and then whatever button on your calculator raises stuff to powers, raise, and then I just go 1 divided by 6, and that's how that works fine on my calculator. And I got me about 1.75-ish. So you're going to have to figure out how to get your calculator to either take a 6th root or raise something to the 1/6 power. It'll do it. You just have to figure out what keys. Okay, these ones I want to do my old trick of rewriting the bases so that they'll be equal. So I think 5 would work here because this is 5 squared and that's 5 cubed. And so I write the 5 squared, but then that x has to multiply with, the 2 on the squared. Okay, and then I'm just going to take these off to the side and set them equal to each other and solve. Oh, and that's it.